Section 8.4. In this section, we are going to learn how to test the polar equations for symmetry, how to graph polar equations. A polar equation describes a curve on a polar grid. The graph of a polar equation can be evaluated for three types of symmetry. The first one is when the graph is symmetric with respect to the line theta equals pi over 2. This is the line pi over 2. If we reflect the graph about this line, we will have the same graph on the other side. And in order to test to see if the graph is symmetric with respect to this line, we will replace r theta with negative r theta. The next type is when the graph is symmetric with respect to the polar axis. This is my polar axis. If I reflect this graph about this line, I will have the same graph. In order to check to see if the graph is symmetric with respect to the polar axis, we are replacing r theta with r negative theta or negative r pi minus theta. The third type is when the graph is symmetric with respect to the pole or the origin. The origin is right here, which means if I reflect this graph about the origin, I will have exactly the same graph. So if my graph is on the first quadrant, I will have a copy on the third quadrant. If my graph is on the second quadrant, I will have a reflection on the fourth quadrant. In order to check to see if a graph is symmetric with respect to the pole, we are replacing r theta with negative r theta. Example 1. Test the equation r equals 2 sine of theta for symmetry. When they ask to test for symmetry, they're asking me to test to see if this equation is symmetric with respect to the line pi over 2, or symmetric with respect to the polar axis, or symmetric with respect to the pole. So we have to do all three tests. First, we are testing to see if it's symmetric with respect to the line pi over 2. In order to test to see if my graph is symmetric with respect to the line pi over 2, we are replacing r theta with negative r negative theta. My original equation is r equals 2 sine theta. Now I'm replacing this r with negative r and this theta with negative theta. And I'm trying to simplify this equation. Sine of negative theta is negative sine of theta because sine is an odd function. So I have negative r equals negative 2 sine of theta. At this point, I will divide both sides by negative 1. And I get r equals 2 sine of theta. I replace r with negative r and theta with negative theta and end up with exactly the same equation, which means this equation passed the test for symmetry with respect to the line theta equals pi over 2, which means this equation is symmetric with respect to the line pi over 2. Next, I want to test for symmetry with respect to the x-axis or the polar axis. In order to do this, I will replace r theta with r negative theta, which means my r will stay the same. My theta will be replaced with negative theta. So I have r equals 2 times sine of negative theta. Again, sine of negative theta is negative sine of theta because sine is odd. So I have r equals negative 2 sine of theta. And I cannot simplify this any further. So I replaced theta with negative theta, and I did not end up with exactly the same equation. That means this equation did not pass the test for symmetry with respect to the x-axis, which means that this equation is not symmetric with respect to the x-axis. Next, we want to test for symmetry with respect to the origin. In order to do this, we are going to replace r with negative r. So my theta will stay the same. My r now is replaced with negative r. So I have negative r equals 2 sine theta, which means r equals negative 2 sine theta. So after replace r with negative r, I did not get exactly the same equation as the original. So this did not pass the symmetry test with respect to the origin. Therefore, the equation r equals 2 sine theta is not symmetric with respect to the origin. So every time you test for symmetry, if you want to test for symmetry with respect to the line pi over 2, you replace r theta with negative r theta. If you want to test for symmetry with respect to the x-axis or the polar axis, you replace theta with negative theta. If you want to test for the symmetry with respect to the origin or the pole, you replace r with negative r. And after you simplify them, you want the equation to be equivalent with the original equation. If it's equivalent, then it passed the symmetry test. If it's not equivalent, then it does not pass the symmetry test. Example 2. Find the zeros and maximum r, and if necessary, find the polar axis intercepts of the equation r equals 2 times sine of theta. They asked me to find the zeros and to find the maximum absolute value of r, and also find the polar axis intercepts for this equation right here. So find the zero means that you are letting the equation equal to 0, and then you solve for theta. So I have the equation r equals 2 sine of theta. I want to find the zeros for this equation. That means I let r equal to 0 and solve for theta. So I have the equation 0 equals 2 sine of theta. To solve for theta, I first solve for sine of theta first. So I'm going to go ahead and divide both sides by 2. So the 2 canceled out. I have sine of theta equals 0. And I'm looking for theta. So theta is sine inverse of 0. I don't have a unit circle, but I have a circle here. At this angle is when my sine equal to 0. Also at this angle, this angle, this angle. At these 2 points, I have 1, 0 and negative 1, 0. So when theta equals 0, my sine is 0. When theta equals pi, my sine is 0. When theta equals 2 pi, my sine is 0. When theta equals 3 pi, my sine is 0. So my theta is pretty much 0, pi, 2 pi, 3 pi, 4 pi, and so on. So that means my theta is going to be a multiple of pi, which is n pi. And my n is integer. N can be negative 1, negative 2, negative 3, or 0, or 1, 2, 3, 4, 5. As long as n is an integer, theta is n times pi. So that means if theta is n times pi, then sine of theta equal to 0, then 2 sine of theta will also be equal to 0. And these are the zeros that they're asking me to find. Next, I am looking for maximum absolute value of r. So I have the equation r equals 2 sine of theta. And I want to know what is my maximum absolute value of r. First, let's look at the maximum of sine theta. So let's look at the graph of sine of theta. This is the graph of sine of theta in one complete cycle from 0 to 2 pi. So in this cycle, I notice that this is the highest point of my graph. So this is the maximum point of my graph of sine of theta. And this maximum point is when theta equals to pi over 2. And that is when sine equals to 1. Okay, so r equals 2 times the maximum value of sine of theta, which means this is going to be your maximum value of r as well, and that is 2. Next, I want to find the polar axis intercepts. To find the polar axis intercepts, remember our polar coordinates are the coordinate with r and theta. To find the polar axis intercept, I'll let r equal 0 and I want to find the corresponding theta. So r is 0 and I want to find that theta. Remember, when r equals 0, theta is n pi. So that means if r is 0, my theta can be 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, and so on. So my polar axis intercept can be 0, 0, 0 pi, 0, 2 pi, 0, 3 pi, and so on. Or you can just say 0 n pi. In this question, they did not ask me to graph r equal to sine of theta, but I want to show you how to graph this as well. So I'm going to add another page and show you how to graph this one. I am going to plot the points in, so I'm going to look for the corresponding pair of r and theta. I will let theta be 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. And I am going to plug these theta in and solve for r. So when theta equal to 0, I plug 0 in here, I will have 2 times sine of 0. Sine of 0 is 0, so I have 2 times 0, which is 0. The first pair will be 0, 0. When theta is pi over 6, I will have r equals 2 times sine of pi over 6. Sine of pi over 6 is 1/2. So I have 2 times 1/2, which is 1. So the second pair is 1 comma pi over 6. This is r comma theta. If r is pi over 3, I'll have 2 times sine of pi over 3. Sine of pi over 3 is root 3 over 2. So I have 2 times root 3 over 2, which is root 3. And that is root 3 comma pi over 3. Then I'll substitute theta with pi over 2. I have r equals 2 times sine of pi over 2. Sine of pi over 2 is 1, so I have 2 times 1, which is 2. And then I substitute theta with 2 pi over 3. R equals 2 times sine of 2 pi over 3. Sine of 2 pi over 3 is root 3 over 2. I have 2 times root 3 over 2. That is root 3. So this I have 2 comma pi over 2. And this is root 3, 2 pi over 3. And when I substitute theta with 5 pi over 6, 2 times sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. 2 times 1/2 is 1. So I have 1 comma 5 pi over 6. And then I substitute theta with pi. R equals 2 times sine of pi. Sine of pi is 0, so I have 2 times 0, which is 0. And it looks like that if I keep going, it will keep repeats. So I will just stop right here. And I'm going to go ahead and plot these points onto the grid. I have the polar grid here. What I'm going to do is go ahead and plot these points on here. So the first point is 0, 0. R is 0 and the angle is also 0. So you start at the pole. R is 0 means you're not going to go left or right. The distance is 0. And the angle is also 0. That means you're not rotating. So this is the point right here. Next point is 1 pi over 6. So your R is 1. You go to the right 1. And you rotate pi over 6. This is your second point right here. Next, I have root 3 pi over 3. Root 3 is about 1.73. So this is about 1.73 and then pi over 3. So 1.73 is somewhere here. And I rotate pi over 3. Which is this point right here. Next point is 2 pi half. So R is 2 and rotate pi half. Have this point. Root 3, 2 pi over 3. So root 3 again is 1.73, is around here. And then 2 pi over 3. This is 1 pi over 3. This is 2 pi over 3. Next point is 1 5 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And then next point is 0 pi. So the distance is 0, you rotate pi, you get to here. So this point is 0, 0, 0 pi, 0, 2 pi, 0, 3 pi, and so on. So if I connect these, that gives me a circle. So after I connect all of the points, I get a circle. This is the graph of R equals 2 sine of theta, and we graph this by plotting the points on here. You can also use technology to graph your polar equations. I use Desmo.com, and after you get here, you click on Graphing Calculator. And from here, all I do is just type in my equation. So for example, I'm going to type in R equals 2 sine of theta. And they gave me the circle. Now, what if I have R equals 4 cosine of theta? I have a circle with the diameter 4. Let's try a couple more. Say I have R equals 2 plus 2 cosine of theta. This is what it looks like. Or if I have R equals 2 cosine of 4 theta. And this is my graph. So you can use Desmo.com to play around with the graphs of your polar equations.